This episode is sponsored by Hired.com. Every week on Hired, they run an auction where over 1,000 tech companies in San Francisco, New York, and LA bid on Ruby developers, providing them with salary and equity up front. The average Ruby developer gets an average of 5 to 15 introductory offers and an average salary offer of $130,000 a year. Users can either accept an offer and go right into interviewing with the company or deny them without any continuing obligations. It's totally free for users, and when you're hired, they give you a $2,000 signing bonus as a thank you for using them. But if you use the Ruby Rogues link, you'll get a $4,000 bonus instead. Finally, if you're not looking for a job but know someone who is, you can refer them to Hired and get a $1,337 bonus if they accept the job. Go sign up at hired.com/RubyRogues. This episode is sponsored by CodeShip. CodeShip is a hosted continuous delivery service focusing on speed, security, and customizability. You can set up continuous integration in a matter of seconds and automatically deploy when your tests have passed. CodeShip supports your GitHub and Bitbucket projects. You can get started with CodeShip's free plan today. Should you decide to go with a premium plan, you can save 20% off any plan for the next 3 months by using the code RubyRogues. Snap is a hosted CI and continuous delivery that is simple and intuitive. Snap's deployment pipelines deliver fast feedback and can push healthy builds to multiple environments automatically or on demand. Snap integrates deeply with GitHub and has great support for different languages, data stores, and testing frameworks. Snap deploys your application to cloud services like Heroku, DigitalOcean, AWS, and many more. Try Snap for free. Sign up at snapci.com/RubyRogues. This episode is sponsored by DigitalOcean. DigitalOcean is the provider I use to host all of my creations. All the shows are hosted there, along with any other projects I come up with. Their user interface is simple and easy to use, their support is excellent, and their VPSs are backed on solid-state drives and are fast and responsive. Check them out at DigitalOcean.com. If you use the code RubyRogues, you'll get a $10 credit. Hey everybody, and welcome to episode 223 of the Ruby Rogues podcast. This week on our panel we have Jessica Kerr.
Good morning.
I'm Charles Max Wood from DevChat.tv, and this week we have a special guest. That's Yorick Peterse.
Hello.
I'm sure I said it wrong, but...
don't worry.
It was American enough, right?
It lacks the certain amount of bald eagles and explosions and everything in the background.
Oh, there we go. You want to introduce yourself?
Yeah, sure. So I'm Yorick from the Netherlands. I've been doing Ruby for several years. Lost count. I do all sorts of nerdy little things. I work on Rubinius. I recently, about a year ago or so, I started working on an XML parser, HTML parser, that kind of stuff. And besides that, I'm basically like all over the place with fixing jams, that kind of stuff.
We brought you on to talk about Oga and parsing and Ruby.
Mm-hmm.
So do you want to kind of give us a quick overview of Oga?
Whew. Where do I begin? It's always difficult.
What does it do?
So Oga is, in short, a parser for XML and HTML written in Ruby. And it also has support for querying documents using XPath, CSS, basically the sort of standard set of features you would expect from a XML parser. I started working on this about a little over a year ago, I think. So at that point, I had a bunch of applications that were using Nokogiri, a similar library, probably one of the, if not the most popular XML parsing library in Ruby. And I was trying to run applications that were using that on Rubinius at the time, and bumped into this particular problem where, for reasons still not entirely clear, it would crash quite often, up to the point where I couldn't decide, like, okay, we'll just deal with the occasional crash and see if it actually yields us any benefits. But it just crashed so often that basically the application couldn't even do anything because it would already crash at that point. So I spent some time together with a bunch of people trying to see if we could fix it. And after several weeks, I decided, like, okay, this is way over my head. So you know what? I'll write an alternative, because that is not way over my head. Initially, I actually thought that maybe I can do that in 2-3 months. Took a little bit longer than that. No, I actually started in February 2014, so it's almost 2 years, actually.
Wow, and that's impressive.
Today, it's at a point where it's actually useful. It's in certain areas not as fast. In certain areas, it will be faster than Nokogiri in the near future. But already people are starting to use it, and perhaps one of the most common compliment I get is that it's so much easier to install because it's much smaller and doesn't require any system libraries whatsoever. So that already is a nice achievement. Although, if I look back at it, I might have been a little bit over-optimistic thinking I could do this in like 2-3 months. Because it's the classical example of trying to shave a yak. You start, and initially it looks okay, and then you bump into this problem. You're like, now we have to do this. And then you fix that, and 2 months later, it's like, oh, now we also have to do that. And it kind of keeps repeating itself.
So I really want to, I know people are going to have questions about this, and I'm looking at it, and it seems like for the most part, it has at least the common features that you expect from a library like this. So you can look things up by CSS, you can look it up by XPath, you can look it up by, several other things. You can extract the data out of it. I kind of want to, I'm kind of torn because I want to talk a little bit about OGA, but the thing that fascinates me is parsing. So since we're already talking about OGA, let's go ahead and talk about that for a little bit longer, and then let's go into parsing, because I think that's a really interesting topic to me. I don't know about you, Jessica.
I'm super fascinated, and we can get back to this by the end of the show, by the part where he thought it would take 2 to 3 months. Also, where he thought where fixing was over his head. But Yorick, you said that writing an alternative is not over your head.
Yeah, let's
it
go
kind of
for that.
fascinates me.
It might be easier to start with that because that's probably shorter to explain. Basically, the problem at the time is that a large part of Nokogiri's code base is in C or Java, depending on whether you use JRuby or CRuby or Rabinius.
Right, because it depends on libxml and libxslt.
So the way they have it is for CRuby and Rabinius, it uses libxml and libxslt, and then for JRuby they use some different Java library, and they basically sort of replicated the whole gem in Java for that. So it's essentially 2 gems in one. The thing there is, for me, my C knowledge, at least at that time, was not extensive enough that I felt comfortable digging through both Nokogiri and potentially the libxml code base, trying to figure out what on earth was going on. There also there were certain things I thought like, okay, this I would want to do differently, or this I don't like, or whatever. So after several weeks, I decided that initially I would sort of as a prototype try to see if I could make something that would work. And that sort of escalated from there on, basically.
Did you find that there was a lot more to Nokogiri than you thought there was?
So for me, it has never really been that. Like, I dislike certain behaviors Nokogiri has, or the fact that it's a pretty big thing to install and whatever. But the code in itself, not necessarily Nokogiri, but libxml, based on the knowledge I have now, I can definitely see why these libraries tend to be as big as they usually are, or as complex as they are, because the subject they're trying to deal with is also quite complex. So there's definitely sort of an understanding came from that.
Yeah, I find it interesting that you went and implemented an XML parser completely in Ruby, because Nokogiri essentially extends to wrap around libxml. So all the parsing actually happens there. And then the rest of Nokogiri is just exposing an API that the programmer can use.
Yeah, so initially, I think for the first 6 months, I guess, into the project, it was pure Ruby, like literally everything. And then once it got complete enough that I could sort of comfortably say, like, okay, this is sort of XML compatible, I started benchmarking things. And especially with larger input documents, where large is like 10 megabytes or more, which isn't really big, but it's a size where if you start testing parsers like this, you'll begin to notice any performance problems and so on. And so here I noticed that, I don't remember the exact number, but I believe that the pure Ruby version was like 10, whatever, many times slower than Nokogiri, with no real room for improvement. And that already was quite problematic. If I recall correctly, I had this file that was 10 megabytes. And basically, only the first phase of the whole parsing process would already take, I believe, like 5 seconds. Now, 5 seconds for 10 megabytes for me is just way too much. Like, I can't tell people you should use this, but it will take you quite a long time, especially if no cookie can do that in, I don't know, maybe 400 milliseconds, for example. So then I made the decision to basically move part of the sort of parsing loop or process to a native code. So for CRuby and Rabinis, that will be C, and for JRuby, that will be Java. But most of the actual logic, for example, the part of code that determines when certain tags have to be inserted automatically to deal with invalid XML, for example, that would all be done in Ruby. And so basically the way it works now is that sort of the loop that basically goes through the input, that is in native code, and that sort of dispatches back to Ruby methods that do the actual work in terms of adding bits to the parse tree and so on. And that made it much faster, but came at the drawback that it's no longer pure Ruby. So right now it's about, I think the GitHub statistics, if there are any accurate, they show about 91% being Ruby and the other 9% being the rest, basically.
So you basically just moved what you had to into C to get it to speed up?
Yeah. And the interesting thing there I found is that at some point I thought, like, okay, what is the overhead of Ruby itself in this process? So I took the first phase called the lexer, which basically takes the input and sort of breaks it up in little chunks that usually have like a type and a value. They're called tokens. And I basically took that part and basically stopped out all the Ruby method calls, so that it would essentially just go through the input and so on. And that would take, I don't remember exactly, but it could process data like a few gigabytes per second. And you add Ruby to the mix, and it suddenly becomes like 100 megabytes, for example. So it was quite a bit of a shock, because I knew Ruby would add overhead, but I didn't expect it to be that bad. However, it did sort of teach me fairly early on to just accept this as this is basically the limit, instead of being like frustrated and trying to make it fast and not really gaining anything.
Now, I want to just clarify a couple of things here. When we're talking about lexers, usually that's something that takes the basically string of code, or in your case, a string of XML or HTML, and breaks it up into tokens, which just represent the structure of the document.
Mm-hmm. Yeah, so the way you can see, say you have, let's say you have the string 10 plus 10, right? The lexer, what it would do, it would take that string and would say like, okay, 10 is a number, plus is an operator, and hey, that other 10 is also a number. And so the result you get could be, for example, an array where it's like 3 different arrays in it, where it has like a type and a value. So it's like array, integer 10, array, operator, plus, whatever, etc. And these tokens are then used in the second stage, which is the actual parsing stage. And they're used here to basically always build a parse tree, which is, as the name suggests, a tree that sort of defines the structure of the document. There are like a bunch of different algorithms. Some parsing libraries, for example, they don't have a separate lexing phase. They do that sort of in one go, which has benefits or drawbacks depending on what side you're coming from.
That makes sense. Usually you hear about this with languages, and I tend to talk about this a lot more on the JavaScript podcast that I do, because there are so many languages that basically transpile to JavaScript. And so it's much better understood over there and much more commonly used. In this case, you're doing a document instead of an actual programming language. Mm-hmm. Do you find that there's a difference between the two in approach?
Yes. So within Oka, there are actually sort of 2 types of parse trees that it builds. For the XML stuff, it basically directly builds the whole XML document in like these Ruby objects that you can query, etc. Whereas for the CSS selectors and XPath selectors, it will first compile it to an actual syntax tree that on itself can't really do anything, or it's just a more refined sort of definition of the syntax. And then there's, in those cases, an extra step, which actually sort of evaluates that syntax tree in order to query your document. In case of languages, usually that extra step takes the syntax tree and turns it into, for example, bytecode, which then a virtual machine can run. Or in case of a compiler, it will maybe turn it into a sort of intermediate format that a compiler can then turn into machine code. So kind of depending on your use case, it's usually Lex or parser and then the thing that uses it, or there can be several steps after. If your program is simple enough, some people, they also only have like a lexing phase, and then the parser parse it, but also evaluates it on the fly. For example, if you're building like a calculator, that could be an option. But so OGA, for the XML and HTML stuff, it just builds the document object right away. And then for everything else, there's sort of an extra step after it. But the sort of core concept of it, it's not that different from programming languages.
Right. So the other question I have then is, does OGA allow you to modify XML documents or build XML documents?
Yes. You can modify, insert, the whole shebang, basically.
And when you do that, do you insert things into the parse tree and then kind of go back the other way or export in a particular manner?
The way it works is that you can, like, say you have your parse document, you can query a certain element and then you can just append directly to its list of child nodes, or you can change attributes directly. But you can also just create an element on its own and then add elements to it. The actual sort of XML classes, like the element class or the document class or whatever, they're used by the parser, but they don't require the parser. They're basically just the result of it. Okay. So you can use them standalone. So you could, in theory, similar to, for example, the builder gem, which you can use to build XML documents using this DSL, similar to that, you could build an XML document without ever using the parser, but just creating an element, adding stuff to it, and setting attributes, etc.
The XML document class is mutable then?
Yes.
Does OGA have to hold the entire document in memory at once to work with it?
The resulting document, yes, if you use the sort of standard parsing method. However, during the parsing process, it doesn't have to keep everything in terms of input in memory. The way you can provide different types of input. You can, for example, just give a string. So if you have like a small chunk of XML, that's probably the easiest way. But you can also give it like a file object or an enumerator, for example. So you could, in theory, do stuff where you download an XML file from the network, and then as you're downloading it, you have it parsed. And then those chunks of input, they only stay in memory as long as they're basically being parsed. However, the result, that stays in memory for as long as there are any references to it.
Okay.
There is ways to do stream parsing, for example. Pool parsing. And it has a Sax parsing API as well.
Wow.
Those are typically APIs you would use if you have like really big documents and you want to have a bit more control over how it's parsed and so on. And those, they typically use far less memory, but they're a bit more difficult to use as a result of being much more low level.
Right. So OGA has Sax's parsing as well?
Yes.
What does it not have?
It doesn't support XSLT, and I don't really have any intentions for that either. At some point, somebody suggested it. I looked at it, and I was like, I prefer not to do that. It will probably depress me a little bit too much.
Yeah. When you talked about extending OGA with C, I'm assuming you used FFI, and that works both in JRuby and C. How do you evaluate your program to say, this would greatly benefit from C, and here are the ways that I need to drop down to native code in order to do the work?
No, it doesn't use FFI. I actually looked into that, but I found it to be too difficult to use. The reason for that is that OGA is essentially from the core built up to support streaming. And that will mean that during the parsing phase, the parser would have to be able to sort of be paused at any stage because it would have to wait for this extra chunk of input to arrive from wherever. The tricky thing there is that certain rules of the parser can emit multiple tokens at once. And so if you would write a classical C program, whenever you would emit a token, you would either you would push it into some sort of array, or you would return it. If you would push into an array, that's probably what you would use if you just want to give back the final result in one go. To return it, then you could actually do streaming, because you would return every chunk without having to keep it around. This, however, is quite difficult if you have to return multiple tokens at once. It's a bit tricky to explain, but the setup I have now is that sort of the native code are actual Ruby extensions. So for JRuby, it uses the JRuby extension API, and for CRuby and Rubin is the C API. And the way it works is that whenever it has to emit a token, it calls back into Ruby, and that essentially yields a block. So every time that block just gets one token. That way you don't have to keep anything in memory for too long. And the setup I have here is essentially that there's a Ruby class which has these sort of callback methods, let's call them that. They're called on element, on comment, etc. And then the lexer calls back into these methods whenever it needs to. And that Ruby code then determines what has to be done with it. Maybe if I look back at it, it would have been nice because you could use the same code on both CRuby and JRuby, sorry. Whereas now I have to essentially mirror some code between the different implementations. Though the way I've done that is in the lexer, there's the set of rules that determine how it has to operate. Those are in a separate file, and I've made sure that the syntax of this file and everything that it uses is compatible with both C and Java. So, for example, if you would look at this file, you would see something like a function call called callback, and it gives a bunch of arguments, and the syntax is compatible with both C and JRuby, Java. And then in the extensions, they define those functions so that they do whatever they have to do for that specific language. So the actual set of rules is reused, and then there's this sort of little bit of support code for both C and Java that then hook that up to Ruby. That way I can do as little in these low-level languages as possible.
Yeah,
and then the parser has a similar setup, though the parser is a little bit more complex. There I also had to duplicate some logic in the actual parsing library that I use, which brings us to parsing. The parser, it used to use this library called RACC, which is a RACC, which, for example, also used by Rails for the routes files they have. And that was, RACC is also written in C. I used that for quite a while. At some point bumped into a problem where, at least for me, it wasn't fast enough. And also RACC parsers tend to be a bit tricky to debug due to the algorithm they use. So if there would be a conflict anywhere in your rules, it would give this weird error saying something like shift reduce conflict. And then you have to figure out what's actually going on. So I wrote a library called RubyLL for that, which is, again, it's part C and Ruby. The actual sort of parsing loop happens in C or Java. And then again, it calls back in Ruby for as much as possible. There I went a little bit further with doing stuff in low-level code than in OGA itself. For example, for this particular parser, I needed dynamic arrays, which in Java are very easy. They're built in the language. But in C, they don't exist. You have to either write them manually, or you have to use one out of 15,000 libraries out there that supports it. Or you have to use Ruby arrays, but I found those would slow things down too much. So what I did there is, for example, for the C code, I had to use this library which basically provided you with dynamic arrays in C. But then I would have to, because that code in itself is not compatible with Java, syntax-wise also, you have to duplicate that with whatever Java equivalents there are. So in this particular RubyLL library, there are basically two bits of code for C and Java that are kind of similar. Like if you put them next to each other, you can see the similarities between the two. And basically the Java version is a sort of direct port of the C version adjusted to actually be Java code. And that was a bit more tricky to write, I guess, than I initially anticipated. That whole process took me, I think, about a month or 3, of which the vast majority was spent reading up on these resources in terms of how you do parsing, how you implement them, what different algorithms are there, which one is suitable for what I need, and so on.
What are some of the resources you look at for that?
When I started doing that, my goal was to write a parser that wasn't necessarily just faster, but also easier to debug and generally just less code to worry about. Rec there, in general, it's a stable library, but it has accumulated quite a bit of code over the years. It's a library from initially, I think, like 2001 or 2 or something. So it's been around for quite a while. And it has these weird conditions where I believe it still supports Ruby 1.8 or 1.9. Not sure which one of the two. So debugging it's not as convenient. So when I started this out, I basically knew nothing about parsing algorithms. I knew a little bit from maybe what I've read on Wikipedia or what I've heard from others. But if somebody would have asked me, like, hey, write your own parser, I'd be like, I don't know how to do that. So the first step there was to find like resources that would explain what different algorithms there are, etc. And I was actually quite surprised that there's not that much available that is really useful when you're completely new to it. I found like tons of PowerPoint presentations from universities, for example, that explain how you construct like parse tables that determine like, oh, if there's this type of input, then you have to go to this rule and do this thing, or else you have to do that, etc. And there were a lot of papers that describe these complex algorithms that you could use and so on. But the recurring problem I found there is that there were very little that actually showed code. And I don't have any form of academic background, so reading these papers for me was pretty difficult. Even though English is a language I'm pretty proficient in, I found them very difficult to read. So I gave up on that fairly quickly. But yeah, I think I spent probably 1.5, maybe 2 months just digging up as much resources as I could with all the frustration that came from it. And I think in the end, the most useful bit was the Wikipedia page on this particular parsing algorithm called LL1. Because that one actually had an example. It had one written in Python and one in C++. Now, sadly, the C++ code wasn't even complete, so that was not particularly useful, but at least it had an example, and the Python one worked. So I then spent probably 2-3 weeks trying to decipher that Python example and translate that to Ruby code, and then from there on, I sort of started climbing up the hill and building on that knowledge. And initially, basically, when I had enough knowledge, I wrote this parser by hand with all the rules like calculated manually. I had like a notebook with pages full, like, okay, if there's this type of input, it has to go here and then do that, and etc. And I then benchmarked that to see if I would generate this code, if it would actually be better. And that particular code was, I believe, already a little bit faster than Rec. Not significantly, but fast enough that it was worth continuing. And I think the end result that I have now, it's like only up to, I think, like 1.7 times faster or whatever. It really depends on the parser, how you've written it, etc. But it was quite a painful process. And one of the things I still want to do is write about it, like write a whole guide. Like, oh, if you want to write a parser using this particular algorithm, this is how you do it. This is, everything you need to know. But that too will probably be a month or 2 of writing work because it's pretty difficult to explain.
I'm curious, what have you learned in the process of building Oga?
Oof, a ton.
What kind of stands out as, something that you don't think you would have learned doing other projects?
Writing parsers, in particular, because the idea of writing an XML, HTML parser itself, or XML library, let's call it that, to differentiate it from regular parsers, that you can do without knowledge of how to implement an actual parser, because you can just use a library like Rack, for example, and you read up on how you define the rules, and that's basically all you need to know. But if you want to understand these algorithms, there is suddenly a ton of stuff you need to know. I guess you can compare it to maybe transpiling to JavaScript versus writing your own virtual machine, for example. There are similarities between the two, but one is like significantly more difficult than the other. And just by doing that, you'll learn a ton of things. But so for me, the biggest gain in terms of knowledge was knowing how to write parsers myself, also understanding, in particular, this LL1 algorithm.
Now that you've done that in Ruby, do you feel like you could do it pretty quickly in a different language?
The particular parser I wrote in LL1, yes. It's kind of a fun thing at that time. It's rather frustrating that these algorithms, when you start out, they look very daunting. And you think like, oh dear Lord, how am I going to do this? But then once you've done it, you look back at it, you're like, that was actually not that bad. And if I look back at this particular algorithm, the algorithm itself is relatively, it's not that difficult. It's just that all the resources are pretty thick and difficult to understand. So you spend a lot of time reading before you actually sort of know what you're reading. So if I would look at this now, I've actually been thinking about porting this particular Ruby LL library to Rust because I might have a need for it myself. There, I've decided to wait with it because it will probably take quite some time. But the actual algorithm, yeah, I could probably port it to different languages by this point.
It sounds like you said that the algorithm wasn't that hard, but you say that after you wrote it.
Yes.
It sounds like it wasn't easy to get started with.
So there are definitely parts you have to understand first in order to understand the algorithm. But if you will look at just the code, for example, the actual code needed for it is not that complex. It's not as if you're trying to write like operating system level of complexity. It's just that it's like a really big doorstep, basically. And that's, for me, if I look back at it, was the biggest problem in this whole process. And I hope that if I find the time to write about it, that becomes much easier for others. So they don't have to go through that same amount of trouble trying to figure out just how they should start, basically.
Yeah, that would be a big contribution to build a ramp up that doorstep.
Yep.
I also find it interesting that the most helpful information that you found had an actual code example, because people can talk about it in English all day, but there's no language as precise as working code.
Yeah, exactly. And it's, I suppose maybe technical papers, if you're native English or if you have an academic background, I suppose papers might be more convenient, but for me, they basically, unless people really recommend them, I sort of avoid them because I know I just won't be able to finish reading them. I just can't get myself through it. But however, if there's an example in code, I can reverse engineer that pretty quickly and then see like, oh, so that's how it works. Oh, well, that's not that difficult after all. But yeah, like in the end, it is the best example you could probably ever get. So in that case, I don't know who wrote the particular Python example of this Wikipedia page, but whoever did it, I probably owe them several beers or tea or coffee or whatever they drink, because without that, I probably wouldn't have gotten as far as I am now.
And you're clearly a very persistent person.
Very stubborn.
So I don't think it's you. I think it's the papers.
Could be. When I was doing this, basically every evening I was banging my head against the wall and I was really asking myself, like, okay, why am I doing this? I should just like stop and do something less troublesome. But if I look back at it, I'm glad I just sort of pushed it through. But I'm glad I'm stubborn, because otherwise probably I wouldn't have gotten this far. But
yeah, it took the stubbornness too. But now you've accomplished it. You've got something useful. If you write something up, then you might become famous.
Fame isn't really a goal for me. I guess it's fun if people are like, oh, hey, you're that person. For me, ultimately, it's about trying to make people's life easier, whether that's by writing something in terms of text or code or so on.
Did you do all of this in your own time, just for your own excitement?
Yes. Basically, like 99% was in my spare evenings, weekends, etc. If I had, like, say, 5 days a week, like unlimited time, I probably could have done it much faster, of course. Now that, for example, at my employer we're using it, I sort of have an excuse to also spend some company time on it, if there are certain parts that need to be improved or fixed or whatever. But it's still like largely a project in my spare time.
How long was it before you were able to use it at work?
I think I didn't get comfortable with it until 2 or 3 months back. By that point, most of the core features we needed were there. Performance was good enough to at least start sort of testing it. And I put it in production for a few smaller applications that we have that are a bit more standalone than the rest. So if they will break or not perform as well, it wouldn't really matter that much. And now at a point where I will be comfortable replacing all our uses of Nokogiri with it, although that's quite a lot of work because we use it basically everywhere. So in total, it probably took a little over a year to get from 0 to good enough.
Did implementing this in like 90% Ruby, 10% C, instead of the other way around in Nokogiri, did it let you make a better API?
That I don't know. The way API is designed is more about the people that write them than what they are written in or what the things they use. The language certainly plays a role. For example, Ruby makes it much easier to write elegant DSLs than, for example, C. I think that the API I have now, Nokogiri could have done just that while still using libxml and so on. It's more that in this case, I had a clean start. I knew what I wanted based on my usage of Nokogiri, but also other libraries. And I also knew what I didn't want. But if any library would basically start over again, the things they use don't necessarily limit them in how they can make their API. The tools I used didn't really affect the resulting API. It was more that I felt they had to be a certain way.
So it was your understanding of the problem and the usage of the library that helped.
Part of it, yes, and part of it is also, bluntly put, personal opinion. I have certain opinions on how I want to do things or how I want to make things and so on. And like when you write your own code, you have that freedom. Whether that has ultimately been the best choice, I don't know yet. That's something you can only judge like several years after when people use it, give feedback, etc. However, so far I've been quite happy with it.
I noticed that so far there's only a few that you've got some contributors with some small pull requests in Oga. Are you hoping to build more of a community around it?
Definitely. I would love for more people to help out with it. I think the difficult thing here is that the topic itself is maybe a bit daunting for a lot of people. Because it does require some reading up and you have to be familiar with the concepts and so on. And for some, XML parsing just doesn't sound interesting. They might want to write a Twitter jam or some library for Amazon, whatever. I've had a few people that have sort of consistently submitted patches for various things. That's absolutely wonderful. The tricky thing there is up until fairly recently, there was sort of a lot of big plumbing going on. Like I would move these big parts around, and especially prior to version 1, it was basically a battlefield in terms of like code flying all over the place. And then like one day I would make this small patch, and then the other day there would be like thousands of lines changed, etc. That's now sort of starting to settle down, which should make it much more convenient for people to contribute. Because I don't have to, I'm like, oh, wait with this because I'm like refactoring this whole thing. But I'm definitely looking forward to having more people submit changes, but also suggestions or bug reports, basically just people using it. I've been keeping an eye on sort of the gems that depend on it, and it's slowly increasing, but I think realistically it will probably take another, let's say, year or two before it's really popular. In the sense that people say like, oh yeah, I'm using Oga, and I'm like, oh yeah, that's that thing, instead of what? But I don't know, it might change maybe in 6 months from now. Everybody's using it. We can only wait and see.
This is one of the places where if you write up how to parse, how to understand this parsing algorithm, that would help you with contributors.
Part of it, yes. Another part there, that's something I've been sort of toying with for a long time. If you look at code, and in particular documentation, for example, usually what you see is the result, like the actual code, and then documentation. Good documentation will show intent and reasoning, for example. Like if there's this weird piece of code, it might say like, oh, we did this because of that reason. However, it's very difficult using these mediums to sort of describe thought. And it's, for me, at least the thought process that guides a lot of things. And so I hope that I can find a way to explain that to people so that they can know, like, oh, okay, so if I want to do this, this is sort of the process I would have to take, or this is the reason why it was taken. Because I feel that will make it more easy to contribute, not just to Ogre, but basically any project that would have that information available. Because it would sort of let people, how would you describe it, sort of transfer themselves as if they transfer themselves into the mind of the original author, so they can sort of think alike, which would hopefully improve the whole contribution process. Because one thing I do notice is that certain parts that are like totally obvious for me, people are like, oh, I thought I would have done it this way. I'm like, no, it's better that way because I've already done this like that many times. How I will explain it, I don't know yet. Probably just a lot of blog posts. Yeah, there's quite a bit of writing up I would have to do before I think more people will be interested, besides maybe the ones that already have like a slightly higher technical understanding of this particular topic. But yeah, we'll basically wait and see, and lots of writing to be done there.
I know I've found in my experience that when I take the time to write something up, it takes a ton of time, but then it's like I've taken that little piece of thought and it's gone from useful to me to useful to hundreds of people. And years later, I'll be surprised. Somebody will be like, oh, that was really helpful.
Oh, yeah, definitely. And for example, doing this whole process of writing these tools, I took a ton of notes in my notebooks. One of the things I've been thinking is trying to scan those. I don't know how useful it would be if it's just scanned papers, but at least you would see the notes I took, the thoughts, the problems I experienced that you might not see in the code directly. But yeah, it's writing all that takes about as much time as writing the actual code itself, if not more. Because with code, you can basically translate your knowledge directly into code in a way that you understand it. But if you want other people to understand it, probably you have to make pretty radical changes, not just to the code, but also the way you explain things and maybe how you think about things to sort of ease that process. Yeah, which is very time consuming. Although it's ultimately, if you do it right, it can be tremendously useful. I think, for example, the best example there, if you look at Rails, the code itself is pretty clear usually, but the documentation is perhaps one of the bigger reasons it's gotten so popular. Like the documentation is probably one of the best examples of good code documentation, and all the Rails guides, etc. So they did a phenomenal job in explaining things, how you do things, etc. But yeah, that was the work of, I think, dozens, if not hundreds of people over many, many years.
Well, that's a great point. That Rails being easy to use, it's not just about the code, it's not just about the API, it's about the documentation. People built that ramp.
Yeah. The thing is, it's especially if you sort of climb the complexity ladder. If you look at typically more low-level libraries, the documentation there sort of makes or breaks it. For example, I've been meaning to learn about LLVM, which is this library toolkit you can use to write compilers, for example. I've been meaning to learn that, but the library itself is really complex, and the documentation is so-so. They have API documentation, which is great if you know what you're looking for. If you're like, oh, there was that class with that one method, what was it called again? And what arguments do I have to pass it? And besides that, they have some basic guides, but in between these sort of absolute basics, like the hello world level documentation and the API documentation, there's nothing. So I've tried it numerous times. Maybe I just couldn't find good resources, but there was a lot better documentation. I probably would have been a lot further in that process than I am now. And if you have a very simple gem, probably you can get away with just a basic example, like, oh, this is how you use it, that's it. But I would say that maybe the sort of the required quality of your documentation sort of scales exponentially relative to the complexity of the code. But that's sort of just a theory.
All right. Well, if people want to find or follow you or follow up on Oga or follow up on parsing stuff or things like that, where should they go?
My Twitter account is probably the best place. It's also usually filled with sarcastic and slightly ranty tweets, so just be warned. But that is at Yorick Peterse on Twitter, just my full name. You can basically find me on that name pretty much anywhere. And probably my website, that's where I would write the bigger articles, which again is just yorickpeterse.com. I'm probably the easiest person to find on the internet.
All right, then, before we get to the picks, I just want to acknowledge our silver sponsors. This episode is sponsored by Code School. Code School is an online learning destination for existing and aspiring developers that teach us through entertaining content. They provide immersive video lessons with in-browser challenges, which means that each course has a unique theme and storyline and feels much more like a game. Whether you've been programming for a long time or have only just begun, Code School has something for everyone. You can master Ruby on Rails or JavaScript, as well as Git, HTML, CSS, and iOS. And more than 1 million people around the world use Code School to improve their development skills by learning or doing. You can find more information at codeschool.com/rubyrogues. I'll go ahead and start us off with the picks this time. The first pick I have is AirPair. If you're not familiar with AirPair, it's airpair.com. And what it is it's a place where people can go and they can get help with coaching or with different areas of interest or topics. It's mostly focused around programming. Anyway, I've been able to help several people there with Rails, with databases, with things like that. I'm starting to get into helping people with Angular. So it's a great place. I'm one of the folks that they match people up with on there, but there are a whole bunch of other people. So if you're running into a problem, you want to sit down with a coach for an hour or so, then that's a great way to go. That's the only pick I have today. Jessica, do you have some picks?
Okay. Well, how about I type and you read my pick?
That's pretty dangerous. I could say anything. So her pick is a shell command. It's cal. It displays a calendar in ASCII on the terminal. Now I got to check this out. Oh, that's cool. I'm so going to use that because I can never remember what day it is. And I'm always on the terminal. So that's like really freaking handy. If you do cal 2015, then yeah, it shows you the entire year. And cal oct 2015 shows you October 2015. But the thing that I'm seeing is that it highlights the day. So if I type in cal, it shows me this month and highlights today, which is super handy. She also points out that cal 15 will show you the year 15 AD. So just keep that in mind. York, do you have some picks for us?
Yes, I have two, actually. First one is called Fish. It's a shell. I started using it since last week. Absolutely love it. It basically does a whole bunch of things like all the suggestions, syntax highlighting. It has a better shell language compared to Bash, at least. And I've been absolutely loving it so far. The second one, and I have to see if I pronounce it correctly, it's ASCII-Cinema. It's basically ASCII Cinema combined into one word. And it's a screencasting application for terminals. And so you start your terminal, you run this command, and it will start recording whatever you type and then upload it. And that's actually been pretty useful also to showing examples, but also how you use things. For example, I used it to show what Fish does, because that highlighting that works better when it's like an actual video instead of just the final text output. So those are my picks.
Awesome. Well, thank you for coming. It was a fun conversation, and I'm going to have to look into using Oga for some of my XML parsing needs.
Yeah, it was great being here.
Yeah, thank you very much. I loved your thoughts on documentation and just how hard it is to do these things.
Yep. And yeah, cal doesn't highlight today's date in my terminal on my Mac, but it does on the Linux machine where I typed it in initially. So
it doesn't highlight it for me on my Linux laptop, though. So that's an interesting difference there.
Yeah, I wonder if it's just some terminal setting or something there.
Huh.
All right. Anyway, thanks for coming. We'll catch everyone next week. Hosting and bandwidth provided by the Blue Box Group. Check them out at bluebox.net. Bandwidth for this segment is provided by CacheFly, the world's fastest CDN. Deliver your content fast with CacheFly. Visit CACHEFLY.com to learn more. Would you like to join a conversation with the rogues and their guests? Want to support the show? We have a forum that allows you to join the conversation and support the show at the same time. You can sign up at rubyrogues.com/parlay.